Hello there and welcome to the Hashpower Academy, your place to learn anything to do with Bitcoin. The topic of today's video is understanding what it costs in electricity and hash rate and how much you earn in Bitcoin by mining one block per day. Wouldn't that be interesting? So first and foremost, let's understand that there is 144 blocks distributed to the entire network per day. Now, to be one of those, you need to represent 144th. And the cost in that is quite lengthy. The first thing to understand is, why is there 144 blocks a day? Well, the network and the blockchain in of itself is also referred to as the time chain, because the Bitcoin software is trying to regulate the amount of time and keep it constrained to about 10 minutes. Why? Because the amount of hash rate of all the different miners coming online, producing and finding blocks, adding it to the chain, well, it's not exactly 10 minutes. And so that difference, that change, if blocks get faster and less than 10 minutes, or slower, more than 10 minutes, that the network looks back 2016 blocks, 2 weeks roughly, to approximate how long did that 2 week period get shortened to or lengthened to. And if it gets shorter, difficulty increases. So the regulation of 144 blocks per day is what the software is trying to do, no matter how big the network gets. And so to understand how much you're getting by producing one block a day, let's understand all the different pieces. So 144 blocks approximates to about 450 Bitcoin of subsidy. Now, this is the key, easy one, 3.125 subsidy per block. That's the easy one. Right, next one down. So 144, and you represent one of those blocks. The network hash rate, I've used 1,000 exahash because by the time you could get enough hash rate to mine a whole block, the network's probably going to be bigger because it's always growing and the difficulty is always increasing. And the easy numbers here is that you can divide 1,000 exahash by 144 because we're just representing one, and it's 6.94 or something like that. Let's round it, 7. So you need 7 exahash of hash rate online, racked and hashing, to produce one block per day with 1,000 exahash network, which is 144th. Now, 7 exahash represents 7 million terahash. That's a lot of hash rate. It's a lot of heat as well. And there is a conversion with those computers. So to understand how much energy we would need as well, we can multiply the amount of hash rate by the efficiency. Now, megawatts per exahash is the same as joules per terahash. It's just bringing the numbers down by a factor on both sides. So it's a multiplier here, and that gives us, I've prepared the numbers quite easily. 7 times 14.28 is 100 megawatts. And here's where it gets interesting. If a very large hydropower station produces about 100 megawatts of power, and one block can be mined with 100 megawatts of power, it means that the network right now at scale is about 144 hydropower stations in terms of power source. That's a good little way of sort of comprehending the scale of this system. 144 100 megawatt power stations, and that's using this efficiency. The average efficiency of the network is still high, closer to 20, so it's a lot more power in a sense. And so we're transitionally going to see more efficient compute come online over time. That's what kicks off the old machines of the network or distributes them more locally to more rural communities as such. But yeah, this is an interesting way to sort of work your way through the commodity chain of electricity, hash rate, and Bitcoin with your one single block example. If you want to scale to the size of a 100 megawatt site producing 7 million terahash to mine your one block and earn 3.125 Bitcoin per day in this 4-year period, well, these are the numbers that you need. Thank you for listening. I hope you enjoyed, and I'll see you in the next video. Goodbye.